Dear friends, this is the lecture number 11 of current electricity. Today we discuss the most important portion of current electricity, the last portion of current electricity almost, that is potentiometer. Like meter bridge, potentiometer is also one device which is very important for your exams. Also its questions are little difficult. I will not tell very difficult. Its questions are little difficult. So you have to understand properly this one. So what is this potentiometer? Potentiometer, just like the meter bridge. In meter bridge, I have told you, one wooden board you will get in the practical lab. This is also in the practical lab. Here also you will get one wooden board like meter bridge. This device you will get in the practical experiment number 4, 5 like this as per the CBSE curriculum. So if you understand today, then it will help you in two ways. You will get the benefit. It will help you in two ways. You can prepare for your exams, theory exams, as well as also it will help you for your practical. What to do in the practical lab also, that one I will tell you today. But what is the purpose of this device? Why this device will read? We have read meter bridge. Its purpose was to measure unknown resistance. But what is the purpose of this device, meter bridge? What purpose of this device, potentiometer? This is a device which can measure EMF of a cell. This is a device which can measure EMF of a cell. EMF means potential difference between two terminals of a cell. If it is a potential difference, can we use voltmeter? Voltmeter can measure the potential difference, because you know voltmeter is a device which can measure potential difference, that you know. So if EMF is just potential difference between two terminals of a cell, see, this is a cell, two terminals of the cell, one is positive terminal, one is negative terminal. If EMF is the potential difference of the cell, then we can use voltmeter to measure. Or not, we can use voltmeter. You see, I am connecting one voltmeter. What is the requirement of potentiometer? Such a big wooden device, what is the requirement of this? Let's use voltmeter. Now use the voltmeter to measure the difference of, to measure EMF of the cell. Okay? You ask yourself, can you able to do? Can this voltmeter measure EMF of the cell? You ask yourself. Can it? You can pause the video here. You think the answer. Why? It cannot measure EMF of the cell. It cannot measure. Why it cannot measure EMF of the cell? You think the answer. Okay, now I am telling you. This voltmeter cannot measure EMF of the cell. Why? When you connect this voltmeter, the circuit becomes complete. Circuit is closed. Now circuit is complete. If circuit is complete, immediately current starts flowing from this end. Voltmeter is a device also, but it has some resistance. It just acts like a resistor now for the cell. So current pass. When current pass, the difference of potential now is EMF? No. The difference of potential, you know, it is less than EMF. Because EMF is the potential difference between two terminals of the cell when no current is drawn from it. This is the definition you have read. When no current is drawn from it. But what happens here? Here now you are drawing the current. When once you draw the current from the cell, the difference is, the potential difference is not EMF. It is less than that. Less than that. Okay? Now you got my point? So, by using voltmeter, you cannot measure EMF of the cell. What you will measure, that is less than EMF. Less than EMF. That is the difference of potential between the two cells, but that is not EMF. You cannot measure exact EMF by using voltmeter. One of my students told me the answer. Sir, it can measure. How? He told, sir, voltmeter will not draw any current if its resistance becomes infinite. That's right. That's right. At that time, the voltmeter is called as ideal voltmeter. Ideal voltmeter has infinite resistance. If its resistance will be infinite, it will not draw any current from the cell. Then it can measure EMF. One of my students told this. Good thinking, good answer, good innovative idea. But the problem is, ideal things are not available in your day-to-day life. They are only to read in your book. They are only to discuss among ourselves. So there is no voltmeter called as ideal voltmeter. That is only to read. Now understand my point? So final conclusion is voltmeter cannot measure difference of potential, cannot measure EMF of a cell. If voltmeter cannot measure EMF of a cell, then what will do? Potentiometer is there. Now all of you understand what is the requirement of potentiometer. Why instead of using a small voltmeter like this, voltmeter just look at a very small device. Or you can use your multimeter also, because voltmeter is there. Instead of using a small device, why you are using a long wooden board? Because that long wooden board only can measure EMF of the cell without drawing any current from it. Now understand? Okay. Now let's come. So everybody now understand the purpose of this device, why it is used. It can measure EMF of the cell. Also it has the other purposes, like it can compare EMF of two cells. That is application number 1 what we discussed. It has also the purpose to measure internal resistance of a cell. It can be also used to measure internal resistance of a cell. So these two applications are in your CBSE syllabus. Okay, so now let's come how this device looks like and what is its construction. So just like meter base, so it's also one wooden board. I am drawing the figure you see here. I am trying also to make it a 3D figure. So this is also just like the meter base, this is also one wooden board. See, this is the wooden board. Okay, so two terminals will be here. One terminal, this is here, and this is another terminal here. But the difference is in meter base only 1 meter long wire is used. But in potentiometer, you can use as much long as possible. As much long as possible. More is the length of the wire used here, the potentiometer will be a good potentiometer. At the end of this portion, I will tell you how the length plays a vital role. Okay, but in some potentiometers you will find in your school practical lab 4 meter long. In some potentiometer you will find 10 meter long. 10 meter long is more good than 4 meter long. But in meter base only we are using 1 meter. You can take also here 1 meter long, no problem. But more is the length, more will be. What advantage you will get, that one I will tell you. Okay, when the length will be more. So now the wires are connected like this. I am drawing the wires now. You see, this is the length. Wires are folded like this. It is equal to fold. Otherwise, how it will make long? Okay, so you see what I have done here. I have made 1 meter, 2 meter, 3, 4, 5, 6. In figure I have done 6 meter long. Okay, in figure I have done 6 meter long. So this is the wire. This wire made up of what? First question comes in the practical fibers. Just like meter base, same answer. Constantan or manganese. Why? First answer, high resistivity. Second answer, think resistance doesn't vary with temperature. Or you can tell low temperature, negligible temperature coefficient of resistance. These are the two reasons. I have already discussed this elaborately in meter base. I am not going to that one. The same constant and manganese alloy it is. So this is the potentiometer wire. To this potentiometer wire, now we'll see what other devices will connect to this potentiometer wire. So now let's come. So here this is the terminal A. This terminal will take it. We'll start the counting from this. This is taken as 0. Then we'll end here as your how much meter? So 600 centimeter. 6 meters, so 600 centimeter. So here from this we'll start. Now we'll connect it. How we'll connect, you see. I have just brought one wire. We'll give current to this one. To give current, what we need? What we need to give current? One cell we need. Okay? One cell, because we have to give a constant current. One cell we need. Then when we give the current, we will not measure it. Yes. To measure the current, what we need? One ammeter we need. Then when you give the current, we will not vary it. Yes. To vary the current, what we need? One resistance we need. Variable resistance. So that we can vary the current. Variable resistance means we can use rheostat, no problem. Rheostat is the variable resistance. So to give the current, we need one cell. You see, I connect one cell. To measure the current, you connect on ammeter. Here negative, here positive. Ammeter terminals are important. You connect on ammeter. Then rheostat. Rheostat symbol you can do. This is the easy symbol of rheostat. It's a variable resistor. Easy symbol of rheostat. You can do the rheostat. Okay. So now these are connected to maintain the current in this wire. But you see one thing. This part I connect cell, ammeter, rheostat. They are only used to maintain current in this wire. They have no other role. Remember, they have no role in the experiment. No role in the experiment. They are only connected to maintain current in the wire. This part has no other role in the experiment. Okay, when we go to the application, we will compare EMF of two cells. You may ask the question, sir, where are the two cells? Only one cell is connected. This cell is only connected to maintain current, and the two cells which EMF will compare, I have not connected to them now. They have not come to this one. So this part has no other role, only to maintain current. Try to understand. So this is called as auxiliary circuit. You know, auxiliary means in dictionary, I think the meaning is supporting. Just it's a supporting circuit. Auxiliary circuit. This one. And this cell is called as driver cell. This cell of EMF E, it is called as driver cell. It is only used to maintain circuit. You can take the example, suppose you have to go to somewhere, to some place. Okay, you hire one vehicle, you hire one taxi. The taxi now come, or one Uber, or in Ola you hire one taxi. So now the taxi come to your house. Then what happened? One person is there in the taxi called as driver. Okay, that person maintain that taxi. Petrol ready, start, okay, and the taxi can move, no problem, everything is okay. But that person, you have to go to some place, but that person has no role in that. That person has no work to go to that place. Suppose you will go to visit some place, then that person is not going to visit. That person is just maintaining the vehicle. Just maintaining the vehicle called as a driver. The same thing here. Also this cell is called as a driver. It has no role. It just only maintain this wire, maintain the current in the wire, just like your driver maintain that vehicle. Okay, and the main person who will go to visit will come after some time. Okay, now the vehicle is ready to go, and the main persons, they will come after some time. I will draw them. But first try to understand this much, because if you not understand, you can't able to draw the circuit from your own memory. And don't mug up. If you mug up these things, you will forget after one day, or after 4-5 hours you will mug up. You will forget. But if you understand, it will remain in your mind for at least for 1 year. It's okay. That is sufficient. Okay, for 1 year. Understand now? So this is called as the circuit. This cell is called as driver. This is the ammeter, which will measure the current, how much current you are giving, and this rheostat will help you to handle the current. I have drawn the simple symbol of rheostat, because rheostat symbol also, another symbol of rheostat is like this. You can take this is another symbol of rheostat. This is the symbol of rheostat also, but I have drawn the easy symbol of rheostat. Simply one arrow mark, that is sufficient. Not required to do like this. Okay, not go to the complicated symbol. Is it clear now? Okay. So now let's come. What is the principle of this device? That is important. We start the principle of this device. What is the principle of this device? Balanced condition of Houston bridge? No. This wrong answer. If you see the copy of board exam, you will find around 30 or 40% students always write balanced condition of Houston bridge, principle of potentiometer. Why they write? Actually, it is not their mistake. Why they write this one? Because this device we are teaching after meter bridge. It is in syllabus after meter bridge, and meter bridge principle is balanced condition of Houston bridge, and always they think balanced condition of Houston bridge applications are meter bridge and potentiometer. So for which they are always telling potentiometer principle is balanced condition of Houston bridge, as it is just after meter bridge. So I told you the common mistake. I hope you will not do in exam. Don't write balanced condition of Houston bridge. It has no role. It has no link with Houston bridge. It is a completely new device, different thing. Not any single part of Houston bridge will not apply here. It is not required at all. Okay, so don't keep in mind this is the application of Houston bridge. No. So its principle is different. We will go to that principle. Okay, so before that, I am explaining you. First I am explaining, then I will tell you the principle. This cell is suppose, I am taking one example. This cell is suppose 4 volt. If this cell is 4 volt, then it provides the potential difference. You neglect its internal resistance, means it provides potential difference of 4 volt. You neglect this rheostat. Rheostat is suppose 0. You have not applied any resistance. Rheostat is 0. If this cell provides 4 volt, then where this 4 volt will drop? Where this 4 volt potential difference will drop? Where is another resistor? This way. This where A to B, this end I am writing B, A to B is another resistor. This is the resistor, another resistor. A to B, this where it is high resistivity. Okay, so what potential difference you are giving 4 volt, that will drop between A to B. Now understand, that will drop between A to B in the wire. Okay, because we have neglected the rheostat, we have not taken any internal resistance of the cell. Now how it will drop? If this is 4 volt, this side will be 4 volt, and this side will be 0 volt. The whole potential difference drop across this potentiometer wire. If this is 4 volt, then this is 3 volt. Let us take here somewhere you take 3 volt. This is take 2 volt, somewhere here you take 2 volt. Here you take 1 volt, here you take 0. Means I am writing the potentials. If this is 4 volt potential at this point, here 0, then this is 3, here 2, here 1, here 0. Okay, now let's see. Now, you between these 2 points, What is the potential difference? Between these 2 points, what is the potential difference? Difference, potential difference I told. Difference means between these 2 points, we will do the subtraction. Okay. What is the potential difference between these 2 points? 1 volt. Between this point and this point, 2 volt. This one I have made fixed. 2 volt. Between this and this, 3 volt. Between this and this, 4 volt. Again I am repeating. Between this and this, 1, 2, 3, 4 volt. What's your mark? Difference of potential when increases, the length of the wire also increases. You see the length, small length increase, difference increase, 2 volt, length increase, 3 volt potential difference, length increase, 4 volt, again the whole length. So, what is the principle? Principle is potential difference directly proportional to length. I hope all of you understood. The difference of potential between 2 points of a wire is directly proportional to length between those 2 points. This is the principle of potentiometer. Principle of potentiometer. The difference of potential is directly proportional to length. Understand? But we can prove it. We can also prove it mathematically. It's not a difficult one. Let's prove. According to Ohm's law, V equal to IR. The difference of potential between these two terminals of the wire. For one wire, we can use Ohm's law, no problem. So, in place of R, what I can write? Rho L by A. Any problem? Nothing. So, this is for the wire only. Okay. So, now I rho by A, take it in bracket L. V is equal to something into L. V will be directly proportional to L if this bracket term will be constant. This is V is equal to K. If K is constant, what is K? K is I rho by A. If it is constant, then only V proportional to L. And the principle of potentiometer will be satisfied. While going to prove the principle of potentiometer, we are getting one again condition that it has to be constant. Means what? The resistivity of the wire, that is constant, made up of one wire. Area of a cross section, throughout the wire, area of a cross section should constant. Current in the wire should constant. Current in the wire should constant. Is it constant now? What connection we have done? Yes. We have connected one cell. Cell gives you direct current, which is always constant. And what about this rheostat? But while doing one experiment, one observation, rheostat you will not vary in between. Rheostat is fixed, current is constant. You will take one experiment. You will do one observation. After one observation, when one observation will complete, you can change the rheostat to take another observation. So, in one observation, current is constant. Okay. So, again I am telling you what is the principle. But in the principle of potentiometer, this condition you have to mention. Current has to be constant, area of cross-section should be constant. Okay. So, again I am telling you the correct principle. What you have to write. The difference of potential between 2 points of a wire is directly proportional to length between the 2 points, provided constant current should pass through it and area of cross section of the wire should constant. If you not write the condition, you will lose a half mark in the principle. Okay? What condition you have to write at last? Constant current should pass through the wire and area of cross section of the wire should be constant. So everybody understand the principle, but here what I told you, V is equal to K, V direct proportional L. So V is equal to K, but what is this K? K we can write here K is equal to V by L. K is called as what? Potential difference by length. Something by distance is always called as a gradient. So V by L is called a potential gradient. Unit is volt per meter. Volt per meter. It's called potential gradient. Now you will understand about the principle of potentiometer. Okay. Now we go to its applications. What are the applications of potentiometer? Now let's come to the applications of potentiometer. What are the applications of potentiometer? We come to the first application. Application 1. Application 1 is compare or comparison of EMF of two cells. This is the application 1. Comparison of EMF of two cells. Just before I told you, the vehicle is ready, your taxi is ready, the driver is ready. Okay, driver is ready. Now the main person who has to actually visit, they will come. So now who are the main persons here? Two cells. Which EMF will compare? Now let's draw them. Now let's draw the two cells which EMF will compare. Bring one wire. One cell you connect. Another wire. Another cell you connect. But important thing is, positive terminal of the driver cell is connected at A. Also positive terminal of the two experimental cells you have to connect it at that point. Okay, that is important. If you connect negative, then you will face the problem. Okay, that one I will tell you. So this is, then here you connect them with a two-way key. This is called two-way key. These are the knobs. With this knob it is connected, with this knob it is connected, and these are the knots, they are connected, and between them they are the gaps. Gaps we can fill by another knobs. Okay. If I here this terminal, this is called E1, this is called E2, this one I am writing 1, this I am writing 2, this one I am writing 3. Okay, and you connect from the third one galvanometer to check the flow of current, one resistance box, then jockey. I have already told you about jockey in the previous class. Okay, so this is the jockey. So here what is the advantage of this two-way key? Once E1 will be connected, then after again observation E2 will be connected. So the two-way key will help you to do it very fast. How? If you put this knob, 1 is connected with 3, 1 will be connected in the circuit. If you put this knob, 2 is connected with 3. Okay, 2 will be connected with 3 and it is connected in the circuit. Okay, so 1, 3, this knob you put, 1 is connected in the circuit. Then you take out this one and put it here. So then 2 is connected and E1 is disconnected. So now you understood? Okay. So next we will go. Now how will you take this observation? You see, I told you first which one will connect? First let's connect E1. Everything, all these are ready. When you will start taking observation, then you will switch on the cell. Not before that. I have told you in the meter bridge, if you do, then temperature will increase. At least resistance may vary small. Okay. Also wires will be slab. So don't do that like that. So now switch is on. So everything is ready. Current is flowing. Cell E1. 1, 3 knob. You now put the knob here. 1 is connected to 3 now. Okay. If 1 is connected to 3, then now the jockey is here. You bring the jockey. And I am telling you about resistance box. From the resistance box, you take out 500 or 1000. I will tell about this resistance box later. What is the advantage of this? Then now 1, 3 knob you put here. E1 is connected. Here is no knob. E2 is disconnected from the circuit. Only 1 is connected here. Then bring the jockey and touch it here. Touch it at point A. When you touch at point A, what will happen to the galvanometer? This is the galvanometer. I will also show. So this one is the meter bridge. This is the galvanometer. Okay. So here is the 0. And this part is covered. This is the galvanometer. Galvanometer like this. See. When you touch the jockey at point A, When touch the at point A, suppose the galvanometer now pointer is like this. Then just take it and touch at point B. Don't slide on the wire. Touch at point B. Then what happens? When you touch at the point B, like this. Okay. Switch is on. Everything is ready. Bring the jockey. Touch at A. When you touch at A, like this. When you touch at B, like this. Then eureka means circuit is now 100% correct. All connections are 100% correct. But if after connecting all these, if one student touching at point A, when touch the jockey at point A, bring the jockey and touch at A, galvanometer is like this. When touch at point B, again galvanometer is like this. What happened? Somewhere some problem is there. This is for one-sided deflection. At A, at B, galvanometer pointer always deflects to one side. Then you will be mad because after doing so many connections, again you are not getting any, because the pointer will never go to 0. You will not get the null points. You will be mad. Okay, you will get irritated. So this, but if in both points after touching they are going in opposite direction, the point is going in opposite direction, means eureka. Okay, means you have done everything correct. If one-sided deflection, what mistakes are there in the circuit? That we'll discuss at the end of this portion. I will tell you so that you will not do that mistake. You will rectify it. Okay. So now again you come. 1 is connected to 3. Cell E1 is connected. You touch at A, one side. Touch at B, another side. Okay. Now that means somewhere we will get the null point. Now what you do? Now you slide the jockey and try to get the null point, because if it is here like this, galvanometer pointer, when you slide the jockey, the pointer will go like this. It will go like this. Somewhere it will be 0. At some place it will be 0. Suppose the jockey at this place I am doing here, you see. Suppose I am making at some place 0. Here I am making 0. Here. Suppose touching at 2, the jockey is now, this is J I am writing here. No place to write, still J. Suppose after touching here, the null point is coming at point J. Okay, so null point is coming here. Why null point is coming there means what? Means at that time no current passes through galvanometer. Means at that time no current passes through galvanometer. Why? Why no current passes through this galvanometer? Why J is the null point like this? So now you see. When no current pass in a wire and when current pass in a wire, first try to think the answer. If there is potential difference, then current pass in a wire. If there is no potential difference between 2 points, suppose potential same, 4 volt, 4 volt. You connect them by a wire. Current will pass there? No, never current will pass. This is 4 volt, this is 4 volt. You connect by a wire. No current will pass in the wire. Okay. So, if there is potential difference, you connect the wire, then current pass. But if there is same potential, you connect the wire, then no current pass. So, see, no current is now passing through it. If no current is passing, if this is 4 volt, so this is also 4 volt. Hence, no current is passing. Because this is 4, this is 4. If this is 2 volt, also this is 2 volt. This side is 2, this is 2, this point is 2, this side is 2, this is 4, this side is 4. No current is passing. That's why no current is passing, because 4 volt, 4 volt. Now you understand? Okay. But what to mark here? So what is the, now no current is passing means the differential potential is called EMF. It is called EMF. Now what is the EMF of this cell? What is the EMF of this cell? No current is passing now. What is the EMF of the cell? 4 minus 2. 4 minus 2, that is 2 volts. 2 volts is the EMF of the cell. We can determine the EMF also like this. This is the EMF of the cell. Okay, so you mark EMF of the cell, this point potential same as this point potential same as this. So we can write here what is the EMF of the cell E1. That is the difference of potential between A and H. Right? Because this potential same as this potential same as this. So what is the difference of potential between two terminals of the cell? That is the difference of potential between A and J. Can you mark from the numerical values what I am writing? 4 minus 2, 4 minus 2. So that is also potential difference between A and J. Understand? So E1 is equal to VAJ, difference of potential between A and J. You have to measure AJ. You will find this to this 1 meter, then 2 meter, then 3 meter, then here some 20 or 30 comes like this. So 300 centimeter plus a 20, 320 centimeter. You write it like this. But I am taking AJ as L, suppose. Then if AJ is L1, then in place of VAJ can I write K alone? I am thinking from where I got it. This is the principle. V is equal to KL. So V is equal to KL I just wrote. Nothing. So this is L1. AJ is L1. So E1 is equal to KL1. This is equation number 1. Now I will connect with cell E2. Now you connect cell E2. If cell E2 will connect, then you just take out the clock key from here and put it here between 2 and 3. E1 is disconnected and this is now connected. E2 is connected. E2 is connected. Again touch the jockey here, one side. Touch the jockey at point B, other side. Okay. Now slide the jockey. Somewhere we will get the balance point. Somewhere we will get. I am showing you again another point. I am showing here. Suppose at this point you will get. Suppose here at this point, that is Z dash. I am writing Z dash. You will get here the knob point. So you again measure AJ dash. How much is the length? Similarly, we can write here also E2 is equal to VAJ dash. How? I have already explained you that. Okay. AJ dash is suppose L2, so this is KL2, equation number 2. Now, one complete observation is over. This is one observation complete. You measure L1, you measure L2. Now you divide these two, equation 1 and equation 2, you divide, what you get here? E1 by E2 is equal to L1 by L2. This is the working formula of experiment. Okay, this is the working formula. Divide these two equations. So you know L1, you know L2, you can compare their EMF. This is all about application number 1. If you want to take another observation, you will change the rheostat. Okay, you just change the rheostat. Means variable resistance you either increase or decrease. Then you take another observation, again E1, again E2, over. If you want to another observation, again you change the rheostat. Again with E1 take L1, with E2 you take L2. Again another observation, you can take the observations like this. So this is about the application 1. Now we'll go to the application 2. What is the application 2? Now let's see application 2. Application 2 is we can measure internal resistance. We can measure internal resistance of a cell. This is the device which can immediately measure internal resistance of a cell. Yes, can it measure? Yes. Internal resistance of a cell, very simple. Already you know this circuit. Driver ready. So your wire is ready. And one cell we need here. So two cells are not required here. So we need only one cell. I am just erasing this one. We need only one cell. Okay. One cell. See, I am connecting one cell here. This is one cell. And another meter. This cell, how much EMF? E1. But another small resistance which is called a shunt. Small resistance in connected in parallel is called as shunt. Remember, this is called as shunt. S-H-U-N-T. name is shunt. And connecting a small resistance in parallel, the process is called shunting. Okay, this is shunt. I am connecting a small resistance in parallel with the cell, and now connect it like this. With the key, you have to connect one key K here. I am writing the key K outside, connected in parallel with the cell. This is the circuit. Now complete only this much stage I did here. Everything is right. So what happens in this case now? Say first cell E1 is connected. First we connect cell E1. This key is open. Open means it is not connected in the circuit. Key is open, not connected in the circuit. Only cell E1 is connected. If only cell E1 is connected, and similarly jockey here, then you slide the jockey, you get the null point here. Suppose you get the null point here, then balancing with L1, then V1 is equal to Vsa, E1 is equal to K1. So this part is okay. This is not required. This part is okay, E1 is equal to K1. You know how to take the observation in the previous application I told you. Now key K is closed. If key K will be closed, this resistance is connected with the cell. If this resistance is connected with the cell, what happens? You see one small circuit here. Cell, external resistance. In this circuit, current starts flowing. Current starts flowing in this small circuit. If current starts flowing in this small circuit, the difference of potential between two terminals of the cell is no more EMF, because now current is drawn from the cell due to this resistance. Due to this resistance, current is drawn from the cell. Now the difference of potential is no more EMF. It's potential difference, that is V. It is no more EMF. This is now V. The difference of potential between two terminals is now V when this key is closed. Okay, so if this is V, V is always less than EMF, means V is always less than E1. V is always less than what? E1, because potential difference is always less than EMF. It is less. If the potential difference is decrease, what happens to the balancing length? Also decrease. So now balancing length will decrease. You will not get the null point more than that. Remember, this is a very important part. Keep in mind. You will not get the null point more than that. Where you will get the null point? When E1 is connected, J is the null point. If J is the null point, when this is connected, this is the null point, J dash. Less comes back towards A. Keep in mind this one. You can check whether you are taking correct observation or not. When the key is being closed, the difference of potential is potential difference, which is less than E1. As the potential difference decreases, so balancing length decreases. So the key will return back. Balancing length will decrease. The second observation will not be more than the first observation. Keep in mind. Okay, second observation will not be more than first observation. Why? I told you, because potential difference decrease is V less than E1. Okay, so in Z dash, and that is L2, so V is equal to V as Z dash. So this is equal to KL2, equation number 2. So this is about now the observations now you take. But what is the working formula for this to measure internal resistance of the cell? Now let's come to this. E1 by V, L1 by L2. Dividing equation 1 with 2. So then what about this E1? We can write in place of E1. Here this is E1. In place of V, what I will write? E1 minus IR. Is it right? Or we can do so, we can subtract there directly. We can subtract there directly, so it will be easy for you. This do minus 1 here, do minus 1 here. Okay, I did minus 1 in both sides. Okay, do minus 1. So it will be E1 minus V by V. This you keep it like this. This part you keep it like this. So imply that E1 minus V is what? This is IR. You know, this is IR. And what is V? V is IS. V is the potential difference between two terminals of the cell. So that means what is the potential difference here? That is the potential difference also here. Across the cell, across the resistance, it just plays the role of external resistance for this cell. Okay, so potential difference here is the potential difference across the resistor. So that is I wrote IS. Okay, so is equal to L1 by L2 minus 1. I cancel. So what is the S now? We need R. So what is R here? L1 by L2 minus 1 whole into S. Over. So this is your working formula to discuss to do the numericals of the application number 2 as well as to do your experiment number 5 in your according to your CBSE curriculum. You can able to do this one. If you put the value of S here, then you get the internal. If you this S value you know, L1 L2 you will find from the experiment. After putting you will get internal resistance of the shell. So this is about the application number 2 of a potentiometer. So now we go, what is sensitivity? What is sensitivity of the potentiometer? Now we go to that part. The last part of this potentiometer, what is sensitivity of the potentiometer? About sensitivity, I am telling you one simple thing. Suppose in class, two students did mistake. Teacher came and scolded the two students. Then what happened? Student A, student B. Okay, one teacher scolded. Then what happened here? Student A now is crying a lot. But what about student B? Has no problem, just smiling like this. Okay, nothing happened. You see the reaction. When teacher is scolding, student A is crying, realizing, repeating what mistake he has done. But student B has no reaction. If I will tell you who is more sensitive, what answer will come to your mind? Who is more sensitive? Obviously you will think the answer that A is more sensitive. When something will tell to A is crying. When the teacher scolded, A is crying. A is more sensitive. Then what is this sensitivity in day-to-day life? I am telling you, I am not going to potentiometer, day-to-day life. Same action, both got same action, but who is showing more reaction? A is showing more reaction, means A is more sensitive. I hope you now got my point. Same action, but more reaction. A is showing more reaction, so A is more sensitive. That one I am going to tell you who is more sensitive. I am now giving you two potentiometers, A and B. Two potentiometers A and B. I am connecting the cell here. This part is not required, only cell. This is off. Okay, only cell is connected here. I am connecting the cell. How much cell I will connect? Suppose I am connecting a cell of 2 volts. Okay. To both potentiometer. To both potentiometer I am connecting. This is potentiometer A. Another potentiometer is somewhere potentiometer B. I am discussing about two potentiometers. Two potentiometers. Okay. One is A, another is B. Okay. Just like this, another potentiometer is also there. Okay. Same cell is connected to both. In this place, in A 2 volt is connected. Also in this place, in B 2 volt is connected. But in A potentiometer, what happens? Jockey is showing the balancing length 400 centimeter. But in B, the jockey is showing the balancing length 4 millimeter. Can you imagine 4 millimeter means where? 4 millimeter means it is very close to A. Very close to A, 4 millimeter. The null point is very close to A, 4 millimeter. Okay. Same action. But who is showing more reaction? See, who is showing more reaction? Obviously, A is showing more reaction. Who is sensitive? A is sensitive. I think now you got my point. What is sensitivity of potentiometer? What is sensitivity of potentiometer? Same action but more reaction is showing. If I will collect, suppose this to this, I will connect 1 millivolt cell to A as well as to B. Okay, I will connect 1 millivolt. Who may measure the EMF? In which potentiometer balancing length may come? You tell me the answer. In A balancing length will come or in B balancing length will come? Obviously, in A balancing length may come. Because if in 2 volt it is showing 400 centimeter, in A balancing length may come. But in B, when in 2 volt it is showing 4 millimeter, means jump is here. 2 volt it is 4 millimeter. If potential difference will decrease from 2 volt to 1 millivolt, from 4 millimeter it will go where? It will come in the well like this. No, it cannot come beyond A. It will come in the well like this. If it is 4 millimeter means it is already here. If I decrease from 2 volt to 1 millivolt, it cannot measure. So B potentiometer cannot measure EMF of the cell. So the potentiometer which is sensitive can measure the small EMF. I am telling you the sensitivity of potentiometer. Potentiometer is said to be sensitive if it can measure very small EMF. If it can measure very small EMF, then that is called sensitive. But mathematical, however, let's do one thing. For both potentiometer now, you see calculate potential gradient. K is V by L. V is the same for both. V is same for both, but L is more here, L is less here. For which potentiometer this A is sensitive? You see, for which potentiometer now K is less? For which potentiometer K is less? Here you see L, because V is constant, L more to K less, L more for this one. So K is less for A. And A is sensitive, I have told you. So how can you check whether the potentiometer is sensitive or not? If potential gradient is less, potentiometer is more sensitive. If potential gradient is less, then potentiometer is more sensitive. K less, then potentiometer is said to be more sensitive. Okay? So one question always comes in exam from this very common question. This one. Very common question, once also came in the board examination. Very common question, this one. Okay, this is A, this is B. Two potentiometers are there. A and B, two potentiometers. Their VL graph is like this. V dash to front L, so graph will be straight line. Okay, which potentiometer you will prefer? Which one you will prefer? You will prefer that one which is sensitive? Which is more sensitive? For which K is less? K is less means, you see, for same V, or you can check here slope provides what? Here slope is equal to V by L. Slope Y by X. Slope means Y by X. So V by L, so that is K. Okay, so you will choose one sensitive potentiometer. I am writing here. Sensitive means less K. Okay, so less K means less slope. So less slope means theta less theta. And for what theta is less? For this one. So answer is A. Which potentiometer you will prefer? A. I am telling you, sensitive means less K. Less K means less slope, because your slope is K. Less slope means less theta. So answer is A. A is said to be more sensitive. Then again another thing. So this is a very important question. Again another thing. Suppose you connect, I told you, if you connect 1 millivolt, it cannot measure, suppose. If one cell cannot measure, means its sensitivity is less, you are telling sensitivity is less. If sensitivity is less, how can you increase the sensitivity? If it cannot measure, means one-sided reflection, how it can measure sensitivity? K is also I rho by A. That become K is also I rho by A. So, if sensitivity is less, means if sensitivity is less, then what you have to do? Sensitivity is less, means K value is now more. We have to decrease K. To make it sensitive, we have to decrease K. We prefer less K. So how K will be less? Rho is not in our hand. It is of the wire. That wire is already made. A area of cross section is already made because potentiometer is given to us. These are the construction. Once potentiometer is constructed means these all are already done. Fixed there. Only is if you want to make K less, you have to make I less. K less K means less I. How can you make I less? How can you make less current in this way? Because current is maintained by this circuit. You can make less I if you increase the rheostat. If you increase the rheostat, then I will be less. If you connect one high resistance in series with this driver cell, then sensitivity will increase. If your cell cannot measure EMF of a cell, you are not getting the null point, you can increase the resistance in series with driver cell. This is all about the theory of potentiometer. I hope all of you could able to understand. But numerical of the potentiometer you can't able to do only knowing this much theory. You have to know more concept about this potentiometer to solve the questions and numericals of the potentiometer. Okay, so in the next video I will tell you the formulas of potentiometer and also how to solve the numericals of the potentiometer. Thank you.